Hello everyone, I am Shiv Prakash. This is Scholar Department of Electrical Engineering, IIT BHU, Varanasi. Let's start for the today's session. In previous class, I taught about the Fourier series analysis and how can you find the Fourier series of a given function, a given signal, which is not a sinusoidal signal. If there is a sinusoidal signal, then the Fourier series is the same as that sinusoidal signal. There is no requirement of to find the Fourier series for that signal. But if there is not a sinusoidal signal, then you can find the Fourier analysis of that signal, and then you can find the harmonics, how many harmonics are there, and how is present harmonics, like order of harmonics. Okay. Now we start about the Fourier transform. How can you find the Fourier transform of a given function? Like other transform, Fourier transform is approximate same. Okay. Same thing, time domain and frequency domain. Xt is a time domain. This is the frequency domain representation. This is the time domain. All of you know about that. Fourier transform of any signal you can find by given integration from minus infinity to plus infinity of that signal and exponential term of that signal minus j omega t. Same thing for the inverse Fourier transform. You can find the time domain 1 by f 2 pi integration of minus infinity to infinity x of j omega e power j omega t into d omega. Okay, let's do for some example how can you find the Fourier transform of that signal. Mostly there is a two formula, you can only two formula to find the Fourier transform. Fourier. Okay, for example, if you want to find a Fourier transform of a point power minus of at ut signal, same thing, use a formula x omega is equal to minus infinity to plus infinity xt into e power of minus of j omega t into dt. Xt is same thing, e power minus at ut minus infinity to plus infinity e to the power of minus of at ut e to the power of minus of j omega t into dt. Okay. There is a ut function, step function available from 0 to infinity. That's why the our integration limit will be changed from 0 to infinity. This will be added e power at, the power is added because of the base are the same. Then e power of minus a plus j omega into t dt. If you integrate e power something, it will be in denominator, and this will be same This is negative, will be negative here. This negative is provided in the denominator, denominator negative is here. You put the infinity here, then this will be 0, e power minus infinity 0, then e power 0 will be 1, negative negative will be positive. This is the Fourier transform of the e power minus of at ut. So if there is a negative term for the same thing, suppose this will be a at and u of minus t is there. Simply replace the t by the minus of t. Then Fourier transform of same, you can use same formula, minus infinity to infinity e to power of at u of minus t into e to power of minus j omega t into dt. For this thing, u of minus t, it means this signal is available from minus infinity to 0. Then limit will be also changed according to this one, minus infinity to 0 e to power of at into e to power of minus of j omega t into dt. 0, this will be add that a minus of j omega into t dt. If you integrate this one with respect to t, then this will be a minus of j omega e to power of a minus j omega into t from minus infinity to 0. If you put a 0, that value is 1, minus if you put the in minus infinity, then e power of minus infinity is 0. Then Fourier transform of that signal will be 1 divided by a minus of j omega. Simple way, if you reverse the t, invert the t as a t is minus of t, then simply you inverse the omega also. For the next example, we take as suppose xt, it will be minus of a mod of t. For this signal, you first of all you break the signal of mod of t, it will be positive, plus of t and minus of t. If you put the plus of t, then it will be e to power of minus of a t ut, plus if you reverse the t, then it will be e to power of at u of minus t. Then simply you can find the Fourier transform of this signal. Minus infinity to infinity xt dt means e to the power of minus of at ut into e to the power of minus of j omega t dt, plus this will be also same minus infinity to infinity e to the power of this will be at u of minus of t to e to the power of minus of j omega t dt. In previous question you know about this integration, and this will be a plus j omega, and this will be a minus of j omega. You can take common of this one, a plus j omega into a minus of j omega. This will be a minus of j omega plus a plus of j omega. J omega will be cancelled out. This will be 2a divided by of a plus b into a minus b. It will be a square minus of b square. If it is square of this one j square, then j square will be minus 1, minus minus will be positive. This will be a square plus omega square. This is the Fourier transform of e to power of a minus of a mod t. Okay, let's check for the another example also, like a delta t. What about the Fourier transform of simple signal? Fourier transform of impulse signal, simply the integration of minus infinity to infinity delta t e to power of minus j omega t dt. For the integration of anything, if you available at del function will be available at only on the origin, or it means 0. Yeah, simply you can provide e to power of minus j omega 0 in place of t, and this will be 1. Fourier transform of delta t is 1. Because of you know about the property of del function, delta t xt dt is equal to x0. Next example, xt is equal to signum t. Signum t function, you all know about this one. This will be from minus 1, this will be 1, so minus infinity to infinity, looks like that. Then this will be written as xt, we written as u of t minus of u of minus t. This will be u of t. If you negative of this one, this function will be there. If you add subtract this one, then this will be a positive one ut. This will be a minus of t, like that, minus of ut, sorry, u of minus t. Then if you multiply of negative of this one, this will be here, become the negative. Or the unit function, if you want to find the Fourier transform of step function, then you can written as this ut, it will be a e to power of minus of at ut, where a tends to 0. If this will be 0, then e power 0 is 1, only ut is there. Minus same thing, written as e power of at, a tends to 0, u of minus t. In the both condition, you know about this one, Fourier transform of this one. This will be 1 divided by of a plus j omega minus, there is minus 1 divided by of a minus j omega. In the both condition, a tends to 0. You take a common, this will be a minus of 2 j omega divided by of a square plus of omega square. In this case, a tends to 0. Put the value 0 in place of a, then x omega will be a minus of 2 j omega divided by of omega square, omega omega will be cancelled out, 2 by j omega. It means the signum t Fourier transform of this signal will be 2 by j omega. Okay. Next one, find the nature of Fourier transform. How can you plot the Fourier transform in frequency and magnitude domain? Plot. Where it is here. Same example I've taken. How can you plot this one? Xt is equal to e power of simple e power a tut. You know about the Fourier transform of this one, 1 divided by f a plus j omega. And what is the magnitude of this one? Magnitude I written as magnitude of x j omega, or written as m magnitude of with respect to the frequency. This is a complex form, then this will be is real square plus complex square. What is the angle of this one? Angle is presented as by theta. This will be a minus of tan inverse omega by a. Okay. How can you plot this one? Magnitude phase, this one will be angle plot axis. This magnitude is the origin. What was at 0? At 0 omega is equal to 0, then 1 divided by root of a square. 1 divided by root of a square, it means 1 by a. This is the value of 1 by a at 0. What about the infinity? If omega is equal to infinity, then 1 by infinity it will be 0. If there is a minus infinity, this is that is minus infinity square, this is also 0. It means you start from minus infinity to plus infinity. If you want to go, then this will be started from 0 to 1 by a, then again it goes to 0 in. It means this will be looks like that. At infinity will be 0. How about the angle? This will be at omega is equal to 0, tan inverse 0, tan inverse 0, it means angle is 0, tan 0 value is 0. Yes, angle is 0. If you put the value at omega is equal to infinity, then tan inverse infinity, it means 90 degree, and this will be negative, then minus of 90 degree, and this will be goes to minus 5 by 2 when the omega is equal to infinity. Out of the minus infinity, if you take the minus infinity here, the minus minus will be positive, then this will be a plus of 90 degree. This will be minus infinity. This is the plot of the Fourier transform for the example of e power minus of 80 ut. This will be 1 by f a, then suppose this will be the 100%, then what is the 70% of this one? 70% is the bandwidth of this function. Bandwidth will be, suppose this will be minus omega 2 plus omega 3 dB bandwidth is there. This will be 70.77% of the 1 by a. It means the a value, put omega value is root of sorry, omega value is A, same as the magnitude of this one. This will be A square plus of omega 1 square 70% of the whole magnitude, it means by root 2 into 1 by of A. This will be a 100% of magnitude, and this will be the 70%. 1 by root 2 is the 70% of the maximum magnitude, peak magnitude. This one. So then what is the value of omega 1? In this case, you can square both sides. This will be A square plus omega 1 square is equal to 1 by 2 A square, then 2A square is equal to A square plus omega 1 square. A square is equal to omega 1 square. The cutoff frequency of this one at 70% is the magnitude of that function. E. This will behave like because of the there is no meaning of the negative frequency, then this will behave like a low pass filter working between 0 to A omega. Low pass filter working between passing the signal between 0 to A only, because of the negative frequencies is not physical meanings of the negative frequency. This is usually positive frequency in this case. The filter will be available, or the as is the low pass filter, which is bandwidth is A and the cutoff frequency is 0 into A. How can you calculate the phase delay of that signal? Phase delay and group delay. Phase delay represented as a TP. This will be phase delay. Young by omega, and total group delay slope of the angle, negative slope of the provide the group delay. For this signal, suppose if you want to find the phase delay TP, simply theta minus of theta omega divided by of omega. In this case, minus theta omega is equal to minus of tan inverse omega by A by of omega, it will provide this much phase delay on your system. And for the same thing for the group delay, theta omega minus d by f d omega minus of tan inverse omega by A. Minus will be common, then it will be positive. Then differentiation of tan inverse theta, tan inverse t, it will be 1 by 1 plus t square. Same thing you can do here. First of all, tan inverse, it will be 1 divided by a t square, it means 1 by omega by a square into this one omega by a, into differentiation of omega by a with respect to omega, it will be 1 by a. Then this will be a, this will be a square, a cancel out, only one a is remaining there, a square plus omega square. Okay. To understand for in example, let's try to solve for the example also. So there is a low pass filter circuit which will be RC circuit. For this circuit, find the group delay at a frequency of 100 Hz and time constant for this filter is 1 millisecond. How can I find the group delay for this filter? Suppose this will be output, this will be input, or this representation of SC in Laplace domain, convert of the Laplace. Correct, it will be possible like that. So this one, you can apply a KVL or you can apply voltage divider rule for this one. You want to find the output voltage, and this will be that impedance. This impedance is 1 by SC into input voltage divided by of total impedance R plus 1 by SC. V output by VA is the transfer function of that circuit to know that HS in Laplace domain, and this will, if you solve this one, this will be 1 by S CR plus of 1. Take a RC common here, S plus 1 by RC. It means 1 by RC divided by of S plus 1 by RC. This is the transfer function of this filter. Then it is given as RC, time constant tau, tau is equal to RC is equal to 1 millisecond. 1 millisecond, it means 10 to the power of minus of 3. For the value of RC, 1 by 10 to the power minus of 3, it means 10 to the power of 3 here, divided by of S plus 10 to the power of 3 here. There is no need of magnitude, you can find magnitude also. What is the angle of this one? Angle minus of tan inverse omega by of 10 q. S is equal to j omega. You can put the value at j omega here. This will be written as like that, minus of tan inverse omega by a is equal to 10 to the power of 3. Then what is the group delay? tau g is equal to d differentiation of this one with respect to the omega frequency minus of tan inverse omega by tan cube. Minus minus will be positive. It is same thing, 1 divided by of 1 plus omega by tan cube square into 1 by tan cube. This will be 10 cube divided by of 10 to the power 6 plus omega square. This is the square of 10 cube is equal to 10 to the power of 6. Omega square written as q divided by f 10 to the power 6 plus 2 pi f 2 square, it means 4 pi square into f. Frequency is given as 100 hertz for the finding of group delay. 10 to the power of q 10 to the power of 6 plus 4 into pi square into 10 to the power f square 2 pi of omega square, then 10 to the power of 4. And calculate this one. 10 to the power cube can common, then this will be 10 to the power cube plus 4 pi square into 10. This will be 0.717 millisecond. Okay, let's start the learn about the property of the Fourier transform. Group delay for any system you can find by this one only. Let's start the property. First property, you know about the linearity. Linearity. If there is a two system, x1 have some Fourier transform of x omega, and there is a x2 also there. The Fourier transform of this one will be x2 omega. If there is another Fourier times signal which will some multiplication of some constant x1t, ax1t plus bx2t, then Fourier transform of this system it will be same as individual of Fourier transform. This is known as the linearity properties. Such as mod of t k e to power of minus of at ut plus ki e to power of ut u of minus t. There is a combination of summation of two functions. This is the x3 like that you can see. Then what will be the Fourier transform of this function? It will be same thing. Find the individual Fourier transform, then simply add up this one. This will be k divided by of a plus j omega plus a. This will be also a minus of j omega. Simply add this one. K 2a divided by of a square plus omega square. Fine. Second property is time shifting properties. There is a time domain signal have some have a Fourier transform of this one. If there is any delay in time domain, that will be reflect to the frequency domain by a exponential form. It will be same as it will be positive negative. Our delay is provided by the negative, and our advanced signal. Suppose there is some advanced that signal is advanced provided by the positive value. We suppose if we provide the both in this case x t minus t naught plus x t plus t naught, then what is the Fourier transform of this function? This will be x omega simple e to power of minus j omega t naught plus e to power of j omega t naught. Because the x omega is in the both system, it will be common. What happens if you provide by 2 here and 2 here? Then this will be x omega e power of minus theta plus e power of plus theta divided by 2. It means, or you can say like the e power theta plus e power minus j theta divided by f2, it will be a cos theta. Cos function is there. This is some example like xt e to power of minus up to t minus 2 is there. How can you find the Fourier transform of this one? So this is the not t, this will be mod of t. How can you find the Fourier transform of xt is equal to e to power of minus 2 mod of t minus 2? Okay. For that type of system, you know about the e power of minus 2t Fourier transform of this one, or e power of at like that. E power of minus of a mod t. Know about this will be a 2a. A here is 2. 2 into 2 divided by of a square. A is 2. It means 4 plus omega square. Same thing if you provide some delay here, simply add some exponential term. This will be 4 divided by of 4 plus omega square into e to power of, there is a negative and point is negative, e power 2 omega. The omega 2 like that. In the system phase, it will be added a linear phase because of the, in this case this will be the same as there is no phase, zero angle of this system. In that system is really zero because there is no complex form here. It's only a real form, that's why this is angle provided in your system will be zero. But if you delay, give some delay here on a time domain, then it will provide some phase. That phase is known as the theta, and that theta will be a minus 2 omega because of e power j theta. The angle of this one will be theta, and magnitude of this one will be 1 because of there is no not something here. There is no nothing here. That's why this will provide a 2 omega. If frequency will be changed, then this will provide the linear phase in your system. It will be looks like that. Negative goes to like that. Slope is a minus of 2. It means time shifting property will causes the linear phase this type of this type of system. Okay, let's talk about the next property. It will be a scaling property. Time scaling property. It says that if there is a time double signal and the Fourier transform of that signal is x omega, if you scale in time domain of that signal by alpha, then in frequency domain it will be affected to the magnitude also and bandwidth also. It will be affected to the both bandwidth and magnitude. You can say it will be a this will be scaling. If you scale something, then this will divide by bandwidth. Bandwidth will be if it alpha is greater than 0 or greater than 1. Sorry, the alpha is greater than 1. Then this will provide us some compression in the time domain, and same thing for the frequency domain is divided by alpha. This will be expansion of that term. Okay, first check by the an example, then you can understand better. Suppose there is a xt time domain signal, magnitude is 1 and from a to a, then what is the bandwidth of this one? It will be b, so it will be e to b. Suppose the bandwidth of this one will be total b by a, b plus in time domain is the total bandwidth of this one. Same thing we convert into frequency domain. So suppose there is a frequency domain omega n, from omega n for the side of the frequency, this bandwidth of in frequency domain is only positive frequency is considered, but in time domain it will be both positive and negative total total span of the entire in the time domain, time axis of the system. There is a bandwidth in time domain, but in the frequency domain there is no meaning of negative frequency or any pause filter. That's why it will be consider only the positive frequency. Suppose if you scale by 2 in time domain, then it will be a minus of a by 2, this will be a b by 2, this will be divided by the time axis, and this will be a bandwidth a plus b by 2. It will reduce, you can say this will be a compressed signal if you scale by 2 greater than 1. Same thing frequency domain, it will be effect on magnitude and bandwidth both. It means in frequency domain it will be 1 by 2 magnitude and omega by 2. then this magnitude will be 1 by 2, and the corner frequency of that signal, it will be a divide by 2, it means expand of this one. Expansion, it means the multiplication up to in time axis, and bandwidth of this one double of that one. You know about this one is a t is equal to 1 by f, that's why it will affected like that. If you increase the t, then what happen? Frequency will be decreasing. That's apply here also. Suppose if we scale this one by less than 1, it will be 1 by 2. 1 by 2 it means less than 1. In this case, magnitude is same, but it will be expand by 2. The bandwidth of that one in time domain, it will be 2 a plus b. Same thing for the frequency domain. 1 by of 1 by a is equal to 1 by 2, alpha is 1 by 2. It means 1 by 1 by 2, 1 by alpha, this will be a 2 x 2 omega. Magnitude of this one will be 2, and bandwidth will be half. Bandwidth in this case, this will be, that means you can say time domain expansion is frequency domain compression, compress the time axis, and same thing for a time domain compression is in frequency domain expansion. Okay, this is the time shifting properties. Next one is frequency shifting properties. There is some signal, so now has a frequency Fourier transform of x omega. If you multiplication of some exponential term in time domain, then that will be effect on your frequency domain will be some delay, a shifting in the time, sorry, shifting in the frequency. This will provide some, this is delay in frequency, this will be advance in frequency. Same thing, if you multiplication of some cos signal, cos omega t into xt, then in frequency domain this will be half of cos, it means e power of j, e power of j omega ct plus e power of minus of j omega ct, can written as here e to power of j omega ct plus e to power of minus of j omega ct xt divided by f 2. Then you can take common 2, then xt have Fourier transform of x omega, And if you xt e power j omega ct, it means omega minus of omega c, this will be positive, plus x of omega, this will be given the positive in advance of the frequency, like that. If there is a cosine term in multiplication in the your time domain and in frequency domain, it will be a delay and advance, both it come. It means the average of the advance and delay. Same thing out. What about the sine term? This will be because of e power j omega ct plus e power minus j omega ct divided by 2j. Then this is multiplication by 2j also here. Remaining thing is x, some delay, minus there is some advance. Because of in between them it will be negative here in the sinusoidal form. Here is a negative. Okay, take some example for this one. Xt, suppose xt is equal to minus of at ut. Then what is the Fourier transform of this signal? It will be a plus j omega. What the magnitude of this one? Root of e square plus omega square. You know about the representation of this one will be looks like inverted bell, a bell, sorry, like a bell. Magnitude of this one will be for 70 percentage will be minus of a to plus of a. Okay, not here. Suppose in xt you have to multiply something cos function, and what happen in your frequency domain, and how can it really change the shape of the or the nature of the signal. Xt is equal to e to power of minus of at ut. You know this will be a the j omega, that's why it will be changes like 1 by 2 x of omega minus of omega c plus x of omega plus of omega c, like that. E power at have a 1 plus j omega, omega to be shifted by the omega c. This will be a half 1 divided by of a plus j omega minus omega c plus 1 divided by of a plus j omega plus omega c. This is a single waveform, it will be double. Same thing, if you multiply by a cos function, it will be double of this one. Between the omega c, this will be omega c, this will be f minus of omega c, this one. Magnitude of this one will be 1 by up 2a. In previous case is 1, but here is 1 by f 2a. In the previous case is 1 by a, because of there is single omega is equal to 0, then 1 by a is there. If you put this will be omega is equal to 0, then this will be 2a. 2a for this one, 2a for this one. For the cutoff frequency for the though by some delay minus of omega c, plus of a minus of omega minus of a. For this one, cutoff frequency will be omega c plus of a, omega c minus of a. Simple, if you multiply by the cosine in any signal, then that signal is divided into two parts. It looks like this one. Okay. Next property is time reversal property. I have some Fourier transform of x omega. If you reverse of this one, simply it will be reversed in frequency. If there is any complex form in time domain, then what will be the effect in frequency domain? Then frequency domain, it will be minus of omega. You have to complex of that signal, then after you have to provide the negative of frequency. If there is a complex and a negative in time domain, then there is only complex form in frequency domain. Okay, let's take some example for this one. Consider a signal xt which is e to power of minus up to t. Okay, let yt is equal to 3x minus of t plus 15 into e to power of j 3t. Then what is the magnitude of y omega at omega is equal to 2 radian per second? It means xt is given here e to power of minus of 2t. Then it is asking about the yt, which yt is the function of xt. It will be, sorry, it will be 3x and minus of 3t plus 15 into e to power of j 3t. It means if you talk about the property, then there is a approximate whole properties there. We have to use this one in this case. First of all, find the Fourier transform of this one xt. Xt is equal to e to power of minus up to t. Then Fourier transform of xt. You know about this one, we already, but 2t ut written as like that. e power 2t u of minus of t. This will be 1 by e power minus of at. You know it will be e power 1 by e plus j omega. This will a is here is 2. Then this will be a 2 plus j omega, plus for this one is 2 minus of j omega. This is time shifting property, you can say. Oh, sorry, not reciprocity. This will be the linearity property. If you add this one, this will be a 4. 2 plus 2 4 divided by up 4 plus omega square. It means you can written as x omega is equal to 4 divided by up 4 plus omega square. Fine. Yt, first of all write as yt is equal to 3 x minus of 3t plus 15 e to power of j 3t. This can be written as also like that is t minus of 3, you can take a common, t minus 5 e to power of j 3t. We have to find the Fourier transform of this one. There's a lot of properties used here. Okay, don't worry. Apply the property by one. Take xt. Suppose I have some Fourier transform of this one is be x omega. Then after this will be, can you try by yourself? Just try, then after I will solve. Okay, let's try to solve. First, after that, this first of all use the sampling of this one. Suppose multiply of 3 t here. Then what is the Fourier transform of that function? It means 1 by sampling 1 by mod of alpha mod of minus of 3 into x of omega divided by of omega by alpha. Alpha should be minus of 3, like that. Then after shift this one by 5, 3t. Okay, shift this one by 5, then x minus of 3 t minus 5, provide some delay by a unit of 5, 1 by mod of 3 x omega by mod of minus 3 into the delay signal provide the j same as omega, 5 omega. This is a 5 delay, that's why there is a 5 omega. Next, multiply by this one 3, and this will be 3 x minus of 3 t minus 5. This will be of 3 divided by of mod of 3. Mod of 3 are also 3. You can written as 3 x of omega minus of 3 into e to power of minus of j 5 omega. 3 will be cancelled out, will be 1. Then after you have provide can view minus of 3 t plus 15. Yes, you can write this one like that. Then after next property is e power of j3t. We provide e power of j3t. This will be given some delay in your frequency also. This will be 1 x omega minus of 3 divided by of minus 3 e to power of minus of j 5 omega minus 3. You have to change this much in your x omega. What is the x omega of your is 4 divided by a 4 plus omega square. You know about x omega is given as 4 divided by a 4 plus omega square. Then put the value at place of omega is equal to omega minus 3 divided by minus 3, and an extra term is e power of minus of j 5 omega minus 3. You have to multiply in this case. Then y omega is equal to 4 divided by 4 plus omega minus 3 divided by minus 3 square into e to power of minus of j 5 omega minus 3. Okay, this will be 4 divided by 4 plus omega minus 3 square divided by 3 into 3 will be 9, the square of minus 3 will be positive 9 into e to power of minus of j 5 omega minus 3. Then what is the magnitude of this one? Magnitude I per j something, it will be 1. Then remove this function. You can take a comma. This will be a 4. 9 4 ja is 36. 36 divided by 36 plus omega minus of 3 square. In the question asking about this magnitude at omega is equal to 2. We provide 2 here, the 2 minus 3 it will be minus of 1, minus of 1 square it will be 1. 36 divided by 36 plus 1 it will be 36 divided by 37. This is the answer. Are there any question? Simply you can use the property. It will looks like a so long question, but take one by one, step by step, by taking the properties. Okay. Next property, similarity or duality property. This property says if there is a time domain signal and have some Fourier transform of x omega, if you replace the x omega, it place of omega is replaced by a t, then the Fourier transform of that signal it will be a 2 pi x of minus omega. Sorry, small x. This will be replaced by that one. This will be replaced by minus omega, or you can put that value at 2 pi f also. This will be in frequency domain, it will be minus of f. Omega is 2 pi f. 2 pi is the scaling. Then if you take a magnitude of this outside, it will be minus of mod of 2 pi. 2 pi will be cancelled out. It means if you convert this one to an frequency domain like a Fourier transform, then it plays of omega. If you put a t, then after you want to Fourier transform of that signal, then this will be simply reversed by this one and multiply of 2 pi into take a negative of omega in the place of t. Put simple value of minus of omega multiply by 2 pi. Okay, take an example, then you will understand better. Suppose xt, same thing, e power of minus of at ut. You know about the Fourier transform of this signal, it will be it is a plus j omega. Okay, but in the place of this omega I want to put a value of t at in place of omega, then this will be a plus jt. Then if asking that one the Fourier transform of this one, after that what is the Fourier transform of this function? 1 divided by of a plus jt. Simply we can provide 2 pi. Okay, e to power of this will be a minus of a in place of t you have used minus of omega into ut u of minus of omega. That's it. 2 pi e to power of a omega into u of minus omega. That's it. Simply first of you there is any in your question, if you see like that it will be converted by a Fourier transform, then you can simply convert to the time domain and use this one. Suppose for example xt, what is the Fourier transform of 1 by a pi t? Then xt is equal to then Fourier transform of xt. How can you find the Fourier transform of 1 by pi t? If you if you will go for the long method like the integration of minus infinity to infinity xt is equal to pi t into e to power of minus j omega t into dt, then this will be taking a lot of time, and this will be a minus of division of minus t. How can you solve this integral? This is also difficult to solve this integral. That's why you have to use the property in this case. First of all, you have to check by putting t, replace the t by omega simply. First of all, replace t at by omega 1 upon pi omega like that. Then check or you remember anything the a Fourier transform of 1 by omega, like that. If you remind this one with any signal which one has a Fourier transform of 1 by omega in form of 1 by omega, then after you can solve this question. If you don't remember this one, then there is a problem. Okay. Signum t have a Fourier transform of 2 by j omega. Okay. To asking about the 1 by pi t, then 2 by jt, simply replace omega by t, then Fourier transform of this one will be 2 pi into x omega, it will signum minus half omega. That's it. Okay, but in the question it will be 1 by a pi t. Then 2 will be cancelled out on both sides. Then 1 by t, j goes to here, pi into j to signum minus half omega divided by a pi t. If you divide here, then divide here also is by pi, then pi will be cancelled out. This will be a j signum minus half omega. By duality's theorem, you can use duality property. You can solve this question by easily by the property. Okay. Next example, find the Fourier transform of 1. How can you find the Fourier transform of 1? You know about the Fourier transform of delta t? Yes, delta, correct answer. You know about the Fourier transform of delta t is equal to 1. Then reverse this order 1. What is the Fourier transform of this one? It will be a 2 pi of del minus of omega. So 1, 2 pi. Yeah, you know about the del function. Scaling in delta form is mod of alpha del of t. Because of the multiplication of because delta is only on 0. If there is no function that there is not no bandwidth is there, then we can change. There to change only the magnitude of that function. That's why minus of omega or plus of omega both are the same. This will be the even function. Okay. 1 by 2 pi del of omega. Then Fourier transform of this one will be 2 pi f. Who can written as this one? There is a alpha is there. The alpha is goes to denominator here. 1 f del f. 2 pi will be cancelled out. Okay. Next example on the basis of same properties. Find the Fourier transform of sin of at divided by f pi t. You know about the Fourier transform of this function 1 by 2 pi minus of a to a is a sin a omega divided by f pi omega. Same thing, replace the omega by t. Then this is the rect function sin a omega a t divided by f pi t. Same thing, multiply by 2 pi into at place of t you can replace by the omega, and 2 pi multiplication of 2 pi, this will be a 1 1 minus a 2 plus a. In there is a t function, this will be a omega axis, or this will be a rect of omega by bandwidth will be 2a, that's it 2a. If you replace a by pi, then what happens? This will be sin pi t divided by f pi t. This will be a rect omega divided by f 2 pi. Omega you can retain as 2 pi f, then 2 pi will be cancel out. This function is known as the sinc function. Sinc t. Fourier transform of sinc t is the rect f. This is the rectangle form rect of f. Sinc t, Fourier transform of sinc t, it will be rect f. Okay. Next property, convolution property. You know about all of things. This one. If there is a function which one has Fourier transform of x1 omega, x2 t have some function of x2 omega. If there is a third function x3, which one is the multiplication of convolution of x1 t, convolution of x2 t. The Fourier transform of x3, in that case it will be multiplication of this one x1 omega into x2 omega. It means you can find the Fourier transform of individual uh, function, then after you can simply multiply this one. The next property is the central ordinate theorem. If there is a function xt, I have some Fourier transform f x omega, and you know about the x omega will be, if you know about this one, x omega is written as minus of infinity to infinity xt e power of minus of j omega t into dt. Suppose in the question asking about the uh, value of Fourier transform at omega is equal to 0, simply at origin omega is equal to 0, then 0, simply place the value at omega is equal to 0, then it will be a minus of infinity to infinity xt dt. It means area of that function from minus infinity to plus infinity is the value of this one. In the same case, if there is a xt inverse Laplace transform of that one, inverse Laplace transform, this will be sorry, Fourier transform. This is Fourier transform. This will be inverse Fourier transform. We know about the formula of 1 by 2 pi integration of minus infinity to infinity x omega into e to power of j omega t into d omega. The asking if the Fourier transform is given in the question, I ask you about the uh, value at 0 in time domain at 0. Then this will be simply 1 by 2 pi integration of minus infinity to infinity x omega d omega. It means area under the curve in frequency domain is the value of the at origin in the time domain. AR omega, it means radian per second, will be converted in the frequency domain. And this will be 2 pi will be cancelled out, minus half into to infinity x dx. No need to convert the signal into Fourier transform. We simply provide the find the area of that signal. Next property is a time differentiation property. If there is a differentiation in time domain, then in the frequency domain it will be multiplication of j omega in the Fourier transform. Simply, if there is a double differentiation, this is the omega j omega square, double multiplication of j omega. Okay, next one property is the integral property. Integration properties. Same thing, time domain have a Fourier transform of x omega, where there is any integration between minus infinity to t xt is dt. Yeah, we can replace this one with tau, another variable tau t tau. This will be x omega division in this case. Same thing, if integration is there, then division of j omega plus some initial condition, initial value also is there na. That's why this will be a pi del omega at value at 0. This is the initial condition. Plus value of that function at 0. Take some example, like find the Fourier transform of signum function, signum of t, by differential properties. Okay, you know about the signum function, minus 1 to 1, xt is there. You differentiate this one with dt xt, then what will be there? You differentiate this one of this function, this will be a impulse or the changes of the at origin. Here is the constant function, this will be 0, constant value is 0, differentiation of constant is 0. Here is changes there. Then what is the value of changes? 1 to minus 1, minus 1 minus minus of 1, it will be 2. This will be written as 2 delta t. It means differentiation of dt xt, it will be 2 delta t. Then this will be j omega x omega, it will be 2 Fourier transform both side, if you taken a Fourier transform of both side, x omega is equal to 2 by j omega. This will be signum function. Next case, suppose next example for integration case, find the Fourier transform of ut, unit step signal. It means there is xt is equal to ut u of t. I know the unit step, it will be integration of delta, sorry, to t, delta function makes the unit step signal. You know delta function delta t, Laplace transform, sorry, Fourier transform of delta t is equal to 1 xt delta t, you know about Laplace x omega is equal to 1. Then x omega in place of xt, ut is there, then ut, it will be a integration of this one. It means u omega in place of x, u omega is the integration of delta t. Then this will be Laplace of transform of 1 divided by f g omega, x omega divided by f g omega plus pi del omega into x 0. U omega 1 by f j omega plus this will be 1 because of del omega, you have to put the value at 0, ut is equal to 1, that's why this will be a pi del omega. This is the initial condition. Okay, next property is differentiation in frequency domain. There is some time signal, however, Fourier transform of this one will be x omega. If there is any multiplication of time in time domain, that will be reflected at differentiation in frequency domain, it will be x omega. D by d omega will be x omega. It means, for the example, it will be xt is equal to e to power of minus of at ut. Then if xt is equal to this one, then what is the Fourier transform of yt? It will be a txt. Okay. You know about the Fourier transform of this function, it will be a plus j omega. If there is any multiplication in t, then what is the y omega txt? It means j d by d omega into 1 divided by of a plus j omega. Differentiation of this one, it will be denominator into in differentiation of the numerator, 1 will be 0 minus numerator 1 into differentiation of omega at respect to the omega is equal to 1, constant will be j here, divided by of a plus j omega whole square. The final is 1 divided by of a plus j omega whole square. Means we can say t e to power of minus of at ut have a Fourier transform of this signal is equal to 1 divided by of a plus j omega. Suppose anything is asking in the question like that, if there is a square term a plus jt square in denominator, then what is the Fourier transform of this signal? If it goes to conventional method, then there will be taken a lot of time for this one. That's why you can go by the properties. Simply you know 2 pi t in place of t, put the value of minus of omega, then e to power of minus of a t at place of t, put the value of minus of omega into u in place of t minus of omega, minus 2 pi omega into e to power of a omega u of minus of omega. In the place of a, you put the value of 1 plus jt, Fourier transform of this function, simply minus of 2 pi omega u में power omega u of minus omega, like that. Okay everyone, I want to stop here for the today class. I will meet you in the next Tuesday. Thank you. Thank you everyone.
Thank you, sir.
Okay, welcome.